Hello, friends. We are in a troubling time when it comes to misinformation. Here at Forbidden Knowledge News, I've always taken an unbiased, open-minded, and responsible approach to presenting my own theories, and the views of our guests do not reflect that of my own. This show is for entertainment purposes only, and any information presented during this show is a live-action role-play scenario. Conspiracies are definitely fun to discuss in a responsible way. My suggestion to everyone that has an audience and presents theories and possibilities should present them as such, and in no way present unsubstantiated information as truth. All that being said, enjoy this episode. Welcome back to Forbidden Knowledge News. I'm your host, Chris Matthew. Today my guest is Mark Gober. First, check out our affiliate Brainsupreme. Brainsupreme contains the highest quality ingredients to start your microdosing journey right now. If you order from brainsupreme.co/discount/FKN15, you get 15% off the entire order. That link is also right in the description. Also, watch the Forbidden documentary, A Cult Louisiana, available on Tubi, Roku channel, and multiple streaming platforms. By watching, it helps us produce our upcoming film, Doors of Perception. Also, get a Rokfin premium membership, rokfin.com/FKN+, and be sure to download our podcast episodes directly through Spreaker. Today I want to welcome back to the show Mark Gober. He is author of several books, including An End to Upside Down Thinking, which won the IPPY Award for Best Science Book of the Year. He is host of the podcast Where Is My Mind? Additionally, he serves on the board of the Institute of Noetic Sciences. Mark, welcome back. How you doing?
I'm doing well. Thank you so much for having me.
Thanks so much for coming back on. I really enjoyed our discussion last time. Today, we're going to discuss your new book, An End to an Upside Down Cosmos. And as we enter this era of discovery and questioning the official narratives that we've been presented, there's more and more evidence to support the possibility that not only have we been deceived about the nature of our systems of governance, but the nature of the cosmos and what we're currently existing in. And I don't identify as a flat earther, but I believe there has been enough evidence presented by independent researchers like yourself to indicate, at the least, severe inconsistencies with the data being presented in the official narratives. And as I was telling you before, this book probably takes the most in-depth examination of these controversial topics, and I can't wait to share your insights. But it's been a while since you've been on. Remind the audience a little bit about yourself and your work.
That's funny. I don't think I had this topic on my radar when we last talked, interestingly enough. Usually the topics come in and then I get hooked. But I never planned on writing books. My background is in business. After graduating from Princeton in 2008, I went into investment banking in New York. So I worked during the financial crisis in New York and then left in 2010, joined a firm first in Boston, but then in Silicon Valley, where I spent about 10 years advising technology-focused companies on their intellectual property strategy, their business strategy, their technology. So that was my world. This very much unrelated to what I've now started writing about. But I had what you might call a spiritual awakening in 2016 while I was still working at my firm in Silicon Valley. At the time, I was basically an atheist or agnostic. I thought that we live in a random and meaningless universe, and that when you die, that's the end of your consciousness. Certainly no paranormal phenomena. That was not part of my worldview. And then initially listening to podcasts and then reading books and scientific papers, I realized that there was a whole part of reality, the majority of it, that I just wasn't aware of. So my whole worldview shifted. I wrote my first book, An End to Upside Down Thinking, which was published in 2018. And then after becoming a partner at my firm, right before everything happened in 2020, I actually left the firm. And long story short, I've written 6 books in addition to the first one, and they span the topics of UFOs, politics, medicine, and the latest one is cosmology.
So what was it that brought you to write this particular book?
I had heard people question mainstream cosmology for a while. I think it's just inevitable, as you know, in this community of people who ask questions, it comes up. So for several years, I heard some people say Earth is flat. And then I would hear other people say, well, I'm not really sure what Earth is, but I don't think it's a spinning globe, or, you know, various things like that. And I just was busy with other topics and never had time to explore it, because when I would hear people talk about it, especially the ones that were skeptical of the mainstream narrative, I'd say, well, that's a really interesting point, but I would need to look into a whole area of science that I haven't spent much time in a while. I'd have to just reconfigure my way of thinking. So I put it off to the side. And I wrote the one, so the Cosmos book is the 7th. The 6th one is called An End to Upside Down Medicine. And that was published November 2023. And I realized that a lot of the people that were asking the same questions that I asked about medicine were coming to very similar conclusions about cosmology, meaning they were challenging the mainstream narrative. Often they'd say, I don't know exactly what this place is, but I know it's not what they're telling us. There are too many inconsistencies. And then what they often said is that, look, if you examine the problems with medicine and germ theory in particular, there are often logical fallacies that people engage in, meaning they'll see data and they'll jump to a conclusion about why the data is explained, but there might be other answers relative to the conclusion they came up with. So the fallacy that's often referenced is called affirming the consequent. And the basic way of explaining it is, if it's true that if it rains, the grass will be wet outside, but just because you see wet grass outside doesn't mean that it rained. What's another explanation? Well, there could have been a sprinkler system. There could have been dew. There could have been children running by who poured buckets of water. Or maybe there were interdimensional beings that came in and poured water and then they snapped back out so you never even saw them. The point is, we could sit here and come up with a million different explanations about why the grass is wet, but what happens in science, they often latch onto one conclusion. And we see this a lot in germ theory with the model of a virus, this intracellular parasite that allegedly causes disease, when there are reasons to question that narrative too. And the scientists often jump to the conclusion that it's this virus particle because they observe certain things, whereas it could be explained by other reasons. I'll give one basic example because this is a really important one. You go to a party and a bunch of people get sick afterwards with similar symptoms. And you're like, look, we caught something. When you say caught, that's very specific because you're referring to a microbe that goes from person to person that's infecting your cells somehow and causing these symptoms. Is that one hypothesis? Yes. But what else could have happened? Could there have been toxins in the building that you were in? Maybe there was something bad in the food people ate or the drinks. Maybe there were a lot of EMFs and 5G, or that people were sensitive to that. Maybe there were similar psychological shocks that people underwent and it caused them to end up having physical symptoms because they had this emotional issue that they weren't correlating with the physical illness. So I give these examples because when you apply this way of thinking of jumping to a causal explanation without considering everything else, you can get locked into a model very easily. And the people who were saying this about medicine, I thought they did such a good job with it, they said, okay, you got to look at cosmology. And then I had some people actually nudge me. And this started in April 2024. I read a book called A Fool's Wisdom by Stephen A. Young. He's a theoretical physics PhD. And he wrote this book, A Fool's Wisdom. And in the book, it was not just about cosmology. It was about many other things too. But he had a few chapters on cosmology. And he said, people came to me with this flat earth theory and I thought they were crazy and I was going to debunk it with my fancy PhD. And I've spent years on it and I can't. And he said in the book, I don't know with 100% confidence what Earth is, but I know with 100% confidence it's not a spinning globe. And I paused because I said, to have that level of education and come to that conclusion and write about it publicly, that's a big deal. So I kind of said, okay, that's interesting. Then I went to a conference a few days later called Confluence in Texas. which I recommend to your audience members. Really great conference, open-minded people. It's run by Alex Zeck and The Way Forward. But there were a bunch of people there who were asking similar questions about cosmology and ultimately nudged me to look at it. That's the short version. When I started looking at it, I said, there's a lot here that this is really important. And actually what happened when I was at Confluence, one of the conversations I had was with a few people, including Yerasimos from Here for the Truth podcast, saying, look, a lot of people here are talking about flat Earth or challenging cosmology, but what does it really matter? Because people still have to pay the bills. They're dealing with health issues. Why does it matter what the shape of the Earth is? And as I've looked into it, I think this is actually hugely important. Because if we don't know exactly where we are, how can we understand our history or what we're doing here? And the last thing I'll say before I pause is that a lot of my explorations up until this point, writing the Cosmos book, is that I was asking, who are we? Why are we here? And I still am asking that. But what I was not asking is, what does it mean to be here? Where is here? Where are we? What is this place? I was very much stuck in the cosmology I had been taught of a Big Bang 13.8 billion years ago, things flying through space. Earth is a spinning sphere rotating on an axis and revolving around the sun. The sun's at the center of our solar system, and we're part of this expanding universe. And that's the basic cosmology. I never really thought to question that.
Great introduction. And as you mentioned, there's multi-layers to peel through when it comes to trying to understand this. And there's many places where we could begin. We could begin with the NASA deceptions, what people could observe with their own eyes. But where did you begin with your research?
I did look at the NASA stuff, even though it's chapter 6 of the book, because it's a natural question anyone would ask is, what are you guys talking about? We have this footage. Look at the pictures. You can go online and see what's going on with it. And I want to say two things. First, the discussion that we're having today and the one that I have in the book is about cosmology. It's not just about the shape of the Earth. It's what is this whole cosmos? So even if you want to talk about NASA's pictures, that doesn't tell you what happened allegedly 13.8 billion years ago, which they're telling us that happened, right? This Big Bang that caused the massive inflation and so forth in the expanding universe. So it's bigger than just that. And it even goes into things like geocentrism versus heliocentrism. Is Earth at the center or is the sun at the center? Of course, most people believe heliocentric, the sun's at the center, that's the mainstream cosmology. But just because we saw a few pictures doesn't tell us those sorts of things. Even Albert Einstein, Stephen Hawking, and many others, they will say very openly, and I quote them in the book, and other physicists, they say, when you look at the observations of things in the sky, you cannot tell whether Earth is at the center or the sun's at the center, just based on those observations. So there's more than just the shape. That's point number one. Point number two is, let's say we are talking about the shape and more things that are local to Earth itself. I was just shocked to find that there wasn't the compelling evidence that I would expect, given how convinced most people are that we live on this spinning spherical shaped thing. Because to me, you'd expect to have direct evidence of that, which would be, very simply, 24-hour footage of the sphere of Earth doing a full rotation. Continuous footage with no editing. We don't have that. What do we often get? We get snippets from satellites or other things that the space agencies put up where it looks like there's some curvature, and they say, look, we're on a spinning globe. What are some of the problems? Number one, the agencies will admit that the last image we have, and this is a still image, a picture, is from one of the 1972 moon missions of Earth from the moon, allegedly. And everything after that has been some kind of artist's rendition or a composite or a CGI. And I quote a NASA artist in my book who says the blue marble picture that we see on all the iPhones that really embedded a picture of Earth in many people's minds, that was photoshopped. That was his rendition of various pieces of data and other things, but that was not just a pure picture. That's really important to acknowledge. So 1972 was the last one, but even the 1972 picture, if you take that as legitimate, it is of a disk. It's a circle. You see part. I mean, if it's a spinning globe, shouldn't we see the full sphere? There's a distinction between a circle and a sphere. That's really important too. Some people get caught in the circular aspect, but we need a sphere, three-dimensional. Okay, what are some of the other issues? Fisheye lenses. Fisheye lens creates artificial curvature. So you could see an image of something and they say, look, we're showing the sphere. There was this it was a Red Bull expedition done by Felix Baumgartner, who's sort of like a daredevil person who went up high in space allegedly and took these pictures, and it showed the curve of Earth, but he used a fisheye lens. That was later admitted. It was because it was an extreme curvature. So we always have to be aware of that. Another thing, I had a friend recently, and a bunch of people have said this, like, Mark, I can't believe you're looking at this issue because I get on a plane and I see the curve myself. I don't even need to think about NASA. Question is, do you see circular curvature or spherical curvature? Spherical curvature would be down and away from you in every direction, because theoretically we're always at the top of the sphere. But what do we see? We do see some kind of circular curvature, but it has to do with the way that our eyes perceive. And this is a really critical point that changed everything for me, because our eyes see in what's known as azimuthal grid of vision. That's the technical term, where basically we see in a dome shape, where it looks like it's a circle everywhere around us, but it's not a sphere. And it has to do with limits in our vision. And it has also to do with the fact that, like, if you're standing on a street and there are street lights all the same height above you, if you're looking down that straight road, it will look like the street lights are going down. It looks like they're going down, but they're actually all the same height. So this is called visual perspective. And it ends up creating, when you apply that perspective where our eyes actually distort things, because they're all the same height, but it looks like they're lower. Wait, that's weird. You end up with this azimuthal grid of vision where you see circularity. You see this dome where it doesn't actually exist in that way. But even seeing that dome, it's not a sphere. So I'll just pause there.
While we're in the inconsistencies of what we're told about the science of our planet versus what we can observe with our eyes, what are some other fundamental problems that you found when it comes to not only our local perception here of what we're on, but astronomy and some of the science behind that?
Well, what I keep finding is that there are these inferences made. Like, the scientists want to tell us what a star is allegedly made of that's like X thousand light years away with any certainty, or what happened at the Big Bang 13.8 billion years ago. And they often, the message is that maybe it comes from the media too. There's a desire to have more certainty than there actually is. Scientists observe things for sure, but then they jump to these conclusions of, oh yeah, well, it's a star this far away, when it could be many other explanations. And it leads to lots of problems, because then what I seem to find is that the anomalies, the things that don't quite fit, they just get brushed aside. So I'll give one example. There's something called the cosmic microwave background, which anyone in your audience can look up. It's this very famous idea that there is a background radiation that can be measured, and it came from the Big Bang 13.8 billion years ago. And based on that background radiation that you can measure, and there are pictures of it ever online, we can infer what happened in the early times. But the model of the cosmic microwave background and the Big Bang leads us to the view that Earth is revolving around the sun in the solar system after billions of years of movement. Not that Earth's at the center, and not that Earth is stationary. Heaven forbid, right? That's actually a lot of scientists who I quote in the book, they really prefer for Earth not to have a special place. It's called the Copernican principle, because if Earth's special, then maybe there's a creator, maybe there's an intelligence. But the cosmic microwave background has anomalies in it. If Earth is not at the center, it should be homogeneous, and it should be isotropic, meaning it doesn't have a preferred direction. But it's actually the inverse. There are these little anomalies where it's not homogeneous and it's anisotropic. It has a preferred direction pointing toward Earth. And actually, these anomalies are called the axis of evil by some scientists, which is pretty interesting, because it shows they don't want anything suggesting that Earth might have a preferred place in the cosmos. And yet this observation, these little anomalies that we'd like to sweep aside, because they're just little ones, they have a big impact on how we might look at everything. So that's one anomaly I'd mentioned that changed my whole view. Because actually, remember this, I took an astrophysics class back when I was an undergrad at Princeton. I didn't major in it, but I was so fascinated in the cosmos, and there were these world-renowned professors there. We learned all about the cosmic microwave background, and some of the observations were in the area in Princeton, in the New Jersey area. And so when I learned about these anomalies and what it could suggest, I said, wow, how could it be that these mainstream, really brilliant physicists at Princeton and elsewhere, they're not looking at the anomalies in the same way, or they're not considering the possibility, wait, maybe Earth is at the center. So that's one big one. Another one I like talking about, and I actually start my book with this, is about dark matter. And interestingly, my very first book, published in 2018, An End to Upside Down Thinking, I started it off by saying this very thing, that according to mainstream scientists, 96% of the universe is made out of dark matter and dark energy. That means mainstream physicists and cosmologists will acknowledge that only 4% of the universe is stuff that we know. But what I didn't realize when I wrote that first book is the problems with that 96%. And I'll start with dark matter. That's the one that I focus more on in the book because of some recent findings. Dark matter was allegedly discovered in 1933 by an astronomer. His name is Fritz Zwicky, and he was observing a cluster of galaxies called the Coma Cluster. And based on the way that the things he observed, basically, there was under 1% of the mass that should have been there under Einstein's relativity theory. And Einstein's relativity theory is basically explaining gravity in a refined way, that space-time is bending when you put mass. Mass in the universe actually bends space-time, which is distinct from Newton's idea of gravity. Newton's idea was that mass is attracting mass. An apple falls to the ground because the mass of Earth is much bigger than the mass of the apple, so the apple comes down. There were some problems with that, though. For example, Newton's gravity is unable to predict Mercury's motion in the sky, so it's not a comprehensive model. So then Einstein's relativity comes in and says, actually, it's not mass attracting mass, it's mass is bending space-time. So it looks like mass is attracting mass, but actually mass is bending space-time. But then we observed, Fritz Zwicky observed this Coma Cluster of galaxies, and he's like, wait, in order for Einstein's gravity to work, there needs to be a lot more mass here because it's not adding up. And it was under 1% of the mass that was needed. This wasn't just a little anomaly. This was like way off. So what did the scientists say? They didn't say, maybe gravity's wrong, maybe Einstein's gravity's wrong, we have to rethink relativity. No, they said, we discovered dark matter. There must be matter there that we don't understand, and that can explain everything. And so many scientists, including Neil deGrasse Tyson, I quote him in my book, famous astrophysicist, says, this is one of the biggest unsolved mysteries that we have out there, this whole dark matter thing. What's happened more recently? An astrophysics professor named Pavel Krupa, anyone can look him up, it's spelled Kroupa. He's got a Wikipedia page, highly credible astrophysicist from the University of Bonn in Germany. He is out there are articles on this, and he's done an interview on it, saying, look, my colleagues and I have spent over 2 decades on this, trying to see if the observations that you'd expect under dark matter are there, and it's not. We have falsified dark matter. It's not there. We have to rethink cosmology completely. So think about this. It's really like a house of cards. Yeah. Because Newton's gravity was there to explain why an apple falls. No one's denying that an apple falls. The question is why? Is it mass attracts mass? No, that's got problems. Then it was Einstein's mass is bending space-time, and that's our quote-unquote gravity. But in order for that to work, you need to have this dark matter that's been falsified. So now we've got a big problem everywhere throughout cosmology. And that to me, it was reason to say, Mark, you've got to be open-minded to everything because the current cosmology doesn't work. And before I pause, I want to say one more really important thing. I want to give your audience this quote from Michio Kaku, who is a mainstream physicist, like well-known. He's acknowledging what's known as it's the lack of a unifying theory in physics. Basically, the 2 leading theories in physics, which is Einstein's relativity and quantum mechanics, which are supposed to explain so much, they're incompatible. So when you bring them together, the equations basically blow up. And that's a problem. That means we can't explain reality. That's basically what it means, aside from the dark matter stuff. And this is what Michio Kaku says. There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something is wrong with the theory. However, in cosmology, we're off by a factor of 10 to the 120th power. That is 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science. And what I would say is, therefore, we need to be open to everything. We can't trust anything in the modern cosmology because, by their own admissions, it's wrong.
According to our ancient past, we at one time did believe that we were on a flat plane. This was adapted at some point by different scientists and astronomers. How and why would they go through this much trouble to create an entire science based on nonsense?
Such a good question. And my first part of my answer is that I think a lot of people who propagate false narratives don't realize they're doing it. They're doing it innocently because they believe certain assumptions that they haven't examined. I see this a lot in medicine with regard to virology. I've asked some doctors, how do you know a virus exists and causes disease? And they'll say, well, there's this PCR test and so forth. But I haven't found anyone who actually knows the fundamental study in 1954, the Enders and Peebles study, that jumped to a conclusion using the affirming the consequent logical fallacy I talked about, and they weren't aware of a lot of these things. So you end up with people who are professionals, and they've got these degrees, and they're basing everything off of assumptions. So you end up with that, but it doesn't answer your question because there are some people that have to know. It could be a small group. I don't know what it is, and then it becomes, well, why would they be propagating this?
Right.
Now, with regard to cosmology, I think there's layers to it. There could be, let's say we have the wrong map of Earth. That could mean that there are resources that are being hidden from us, which means there could be a financial reason to do it. And coming from the business world, that always makes sense. Like there's a financial reason. You could jump through a lot of hoops if your livelihood is dependent on it. If you can keep people dependent on energy or who knows what else, because you've hidden things, that would be valuable to do. But I think there might be something more fundamental on a spiritual level, and that's where all my work has gone since my first book, An End to Upside Down Thinking. My basic metaphysics is that we are spiritual beings, and that our consciousness survives after we die, and that we're all part of we have an individual consciousness, but we're also connected as part of a bigger consciousness, something like that. Mm-hmm. And what can be done with an incorrect cosmology is basically hide who we are or hide our significance. So if we believe that we're this tiny speck in a massive universe, and we don't have a special place, that's the Copernican principle. We don't have a special place. We don't occupy anything unique. Then we might believe that we're less important than we actually are. And that could have an effect on our consciousness. And if our consciousness is a fundamental part of physical reality, what does it mean for reality if we're all steered in the wrong direction? I think that's one part of it. And another part of it might just be that if we are living in a massive lie, basically, where we believe our location is not what it is, then we might, on a subconscious level, know that we're living in a falsehood. And maybe that keeps us less healthy, it keeps us weaker, and it keeps us in a place where we're not trusting our senses. So what do I mean by that? I mean, if we weren't told by scientists the following things, I'm not sure we'd believe it. We're told that Earth is simultaneously spinning on a tilted axis at roughly 1,000 miles per hour at the equator, which is faster than the speed of sound. Yet at the poles, at the bottom and top of the sphere, it's barely moving at all. So we have these like variations in speed, and also we don't feel any of it. And at the same time, Earth is free falling around the sun at over 66,000 miles per hour. We never feel any of that. And we're revolving around the Milky Way galaxy at over 500,000 miles an hour, all while moving outward in this expanding universe at over 1,000,000 miles an hour. And we're told that, well, the motion is so constant that you never feel any of it. There's not even a little bump that you feel, and you're just a speck on a tiny ball. It takes a lot to believe all of that versus what does it feel like? It feels like we're in a stationary place, and we never see the down and away curvature. We never see spherical curvature. So our senses would tell us we don't live on a sphere. We might just live on a big plane or something. I don't know what, but it's not what it's not that model. So, but we're told disobey your senses. The experts know what's best. So there might be a spiritual harm in getting people to live in falsehoods where they're disobeying their senses, maybe where we're just so confused that we can't figure out what the powers that be are actually doing to us because we're so out of alignment.
Now, when you mentioned the speed and rate that we're traveling and spinning, many would argue that it's the same effect as being in a vehicle or traveling in a plane where you're not feeling the inertia even though you are traveling at a very rapid rate of speed. What would you say to that?
Yeah, I think those examples, which I've heard and I've had to think about myself, when you're on a plane and there's any bit of turbulence, you feel it. So changes in motion, acceleration, deceleration, you will end up feeling it. Same thing in a car that's not moving very fast. You feel a tiny bump in the road. So we're basically asked to believe that we're moving in just perfectly constant motion in all these ways. There's never any variation in it. And Earth allegedly has an elliptical orbit around the sun, which wouldn't be perfectly constant. So I just think you'd have to believe in something that doesn't seem to align with like belief. Whereas if let's think of an earthquake, We feel an earthquake. Like if there's any change in motion, we don't have earthquakes all the time, but there are some instances where just things change a little bit, and in which case you feel it. But we never even contemplate that we'd have to worry about even a blip on the radar of our motion. I mean, the surgeons aren't having to think about, oh, what if Earth moves in a different way, and I'm this performing this precise surgery, or people who are building these sculptures where the rocks are put on top of each other. You know, any movement would make that thing fall, or playing a game of Jenga. We never have to account for it because we're just told to believe that it's just perfectly constant rather than just saying, well, it's stationary because it seems like it is.
This is so interesting. Now, in your book and in general, you've been communicating with ChatGPT, and in many instances, you have gotten ChatGPT to, in a sense, agree and question some of the science that it was being presented.
Yes. So, and that was actually, it's a useful research tool just to see what the mainstream is going to say about anything, because that's ChatGPT, whether it's virology, consciousness, cosmology, it starts with consensus, but it's also a logical machine. So when it's presented with information and given the source material, sometimes it will be forced to acknowledge certain things. And it can take some nudging where sometimes it will refuse to, but then if you say, well, no, if this, then this, you have to admit it. Eventually it will. And this could be Google's Gemini AI or Anthropic by Claude. There are many AI engines that I've used, and I've presented it with a lot of this information. And it admits, I cannot confirm that Earth is a spinning ball. And in one of them, I can't remember exactly what it was. I post these on my Instagram if your audience is interested, _author, where it's basically said that I think it's a very low probability that Earth is a spinning ball, given everything you presented, where I just like took parts of my book and plugged it in. And there are different ways of playing with ChatGPT if your audience is interested. Like sometimes I find that if you present it piece by piece, you say, okay, here's this piece of evidence, like the dark matter falsification. I want you to walk me through the implications of that, because really, we don't know if gravity is real. And eventually they admit that. And if you admit gravity's not real, then all sorts of cosmologies become open to possibility. And then you present it with something else, and then something else. And if you do it piecemeal like that, eventually it starts to break down versus putting everything in one prompt. So they're just different techniques. The point is, ChatGPT and others, they all end up being forced to admit that the current cosmology is not correct. And they do the same thing with virology and otherwise.
Before we move on to what's beyond our atmosphere, let's talk about what people are calling the firmament, the observations that we can make even with rocket launches, at least in more recent rocket launches that SpaceX have made. You can observe the rocket until a certain point, and it appears to curve off and not continue to go straight up into outer space. I remember the old rocket launches when I was growing up. You would at least be able to see it to a certain point. It always heads straight up. But I've seen different videos that cannot be confirmed or denied where it shows the rocket is hitting something whenever it reaches a certain height. And I'm just curious as to your thoughts as to what is surrounding what we're on.
Well, your point about rocket footage is really important and intriguing to me, because one of the complaints of, let's say, cosmology skeptics, globe skeptics, they'll say the footage is not continuous. When you see the rocket going up and then it cuts out and you see the footage from the perspective of the rocket. Let's see it all continuous footage going into space, and we don't have that direct evidence. And some people would say, well, that's okay. That just has to do with the way the videography goes. But in the absence of that, there are issues with physics too, in terms of the current narrative. The current narrative is that we coexist peacefully next to a near infinite vacuum of space. And a vacuum in this context means basically almost no pressure there. And things are floating around in space. And when you get high enough up, things are floating around, and it exists next to Earth, which has an atmosphere. But under the current cosmology, Earth is not in a closed system. So the atmosphere is sitting next to this vacuum that has low pressure. Our atmosphere is not as low pressure as the near infinite vacuum of space. So you end up with this differential. It's known as like a pressure gradient, where you've got a vacuum and you've got a system that's supposed to be open. But wait a second, why isn't our atmosphere flowing out into space? Because that's what we observe in basic pressure physics. And the example that's often given is if you have a can of soda. You open the can of soda, and inside the can, there's a high pressure there's higher pressure in the soda can than there is outside. So when you open the can, it makes a loud noise because the higher pressure from inside the can's flowing out to equalize, basically to reach this more harmonious state.
Mhm.
And it's known as diffusion of gas. So the question becomes, well, why doesn't that happen with our atmosphere? Shouldn't our atmosphere be diffusing out into the lower pressure system, just like the gas particles in the soda can do when you open it up, because it's higher pressure in the can, then you open it up and it moves out to the lower pressure?
Right.
Why isn't that happening with our atmosphere compared to the vacuum of space? And this should be way more extreme than the soda can and the air around it, because we're talking about a near infinite vacuum. This is massively low pressure stuff, and so there should be a lot of basically energy to try to equalize this differential, but it doesn't happen that way. So what do scientists say? They say that gravity holds in our atmosphere, and therefore it can coexist peacefully. But there are many people, including Stephen A. Young, who I mentioned. He wrote A Fool's Wisdom, the theoretical physics PhD. He says, that doesn't make any sense. There should be basically our atmosphere should be violently pulled out by this differential. So that leads people to say, well, maybe we are actually in an enclosed system, because that would make sense. But then it also means we don't necessarily have to have a vacuum of space. We could have some kind of a fluid medium beyond this enclosure. But in any event, there must be some kind of enclosure under the current cosmology, because you can't have the vacuum next to our atmosphere. And this enclosure is often known as the firmament, and it's described in the Bible. The Bible talks about the waters above and waters below, which leads people to believe there isn't this vacuum space. But it becomes complicated, because then it's like, well, what's the narrative of space agencies and SpaceX? Because they're telling us things are happening based on a cosmology of gravity, of Einstein's relativity, of the vacuum of space, and all this stuff. So to me, that was one of the light bulbs that went off, is they're telling us a narrative of space that we can show based on just normal physics doesn't make sense. There's a mismatch here. But your question still remains, what is above us? I mean, I don't think we really know for sure. I mean, there was something known as Operation Fishbowl and Operation Dominic, which occurred decades ago, of these alleged nuclear weapons being shot up into the sky by the government. Like, why were they doing that? Some say, well, they were trying to send these explosives up there to see if there's a firmament enclosure. But until we go up there and actually observe for ourselves, I don't know if we can know with certainty what's there.
There's been some very interesting discussion about our satellites that are actually being launched on balloons, and they may not be as high up in the atmosphere as we're being told. What are your thoughts about that?
Yeah, it's another one. I'm not quite sure. I think there are lights up there in the sky moving around, but the question is, what's the mechanism by which they're there? Are there satelloons? And actually, I do quote in the book examples of this from government agencies. They have sent satellites up with balloon technology. But it's hard to know exactly what's going on up there, because there could be technologies that the public is not aware of, like anti-gravitic quote unquote technology, where they're using who knows what kind of electrostatic type technologies. There's something I mentioned in the book called the Hutchinson effect, where he was able to make large objects levitate using electricity, basically. So there are these properties of electrostatics that might be able to allow objects to move up in the sky. Also, the introduction of ether, which used to be known as the fifth element, and it was essentially taken out of our physics based on an interpretation of a study in 1887 called the Michelson-Morley experiment, and also an experiment several years before by George Airy, which is known as Airy's failure. But these two studies, if they're interpreted a different way, could mean that we do have an ether. So some call it Airy's success. But if there's an ether, there could be ether-based technologies whereby you could have machinery that's up in the sky. My point is that we need to be creative in understanding what's up there and how it's being operated up there. And it might be some combination of a lot of different things. There could be some balloons. There could be some using technologies that we don't fully understand. I do think there's stuff in the sky floating around. I just don't know exactly what it is. But some have claimed that basically, based on the size of what we're told satellites are, we wouldn't be able to see them as brightly as they appear in the sky based on their elevation. And I do mention that in the book, but it's one of those areas I don't fully understand what's going on with it. But I don't think it's I don't think it throws out these questions of cosmology, if you know what I mean. Like, I think we can still question the cosmology, and there still could be stuff floating up there in the sky.
What about impact events, meteors, asteroids? I personally have never seen one hit the ground. I've seen shooting stars. I've seen what may appear to be meteors in the sky, but again, I've never witnessed an impact event, but we hear about this quite often. Believe that there have people who have witnessed this. First of all, where is this coming from, and what do you think that we're witnessing when we're seeing this?
Well, we run into very similar questions of problems of logical fallacies, affirming the consequent. Something fell from the sky, therefore it came from outer space.
Mm.
Is that true? Maybe. It could
Right.
be, but then what other things could explain that? I don't know. There's government ballistic technologies, other civilians, people running tests. There's a lot of reasons. Some people even speculate if we do have some kind of a firmament, there could be things that fall. I'm not saying I know what the answer is, but just because something fell from above, which like you point out accurately, most people have never seen that actually happen, but we don't know why. That's point number one. But then also we do have these quote unquote craters. And I say quote unquote crater because crater implies that there was an impact event that caused the formation. But especially for the big craters, if there was that big impact event, you would expect the thing that caused that massive crater to be there.
Yeah, yeah.
Because if it's that big, it doesn't just move on its own. And there wouldn't just be little pebbles. You would expect some kind of massive thing that's never found. The other thing with these alleged craters is that they have, it's as if the thing would have fallen straight down. There aren't skid marks. Because if we do live on a sphere, shouldn't these meteors or asteroids, even if they're small, shouldn't they be coming in at all angles? Or like shooting stars even. I know it's not exactly what you're asking, but it's related. If we're on a sphere, shouldn't they sometimes be coming up from the horizon? No, all this stuff, it doesn't really match that. So we would expect more variation in, let's just say, shooting star motion, and we would expect more variation in these crater impact things where there'd be more skid marks and we'd be able to see the thing that impacted it. But we see much more uniformity, which might mean, and some have speculated, that these are just geological formations. Who knows if we're talking about past civilizations, maybe these were something like that. But even like geysers, I quote in my book that geysers, when they're not active geysers, might look a lot like what a crater looks like. So there's a lot of other explanations versus just the things coming from us from outer space.
I find it humorous at times, the mental gymnastics that are attempted when trying to explain eclipse mechanics and how this works. It never will make sense to me, and it never can be explained in a way that could logically fit any of the narratives that we're being told. So I'd love to get your thoughts on, first of all, what doesn't make sense about what we're being told about the eclipse and what we could be really seeing here.
Okay, I'll start with what doesn't make sense because I have an easier time with that. And you're actually raising an important point here, which is that it's not necessary to come up with an alternative model when trying to falsify one model. And people do get confused with that, where they're like, look, if you can't tell me what the right answer is, then I'm just going to stick with what I believe the mainstream says. That's not logical. And the example I give in my book is, let's say you're taking a multiple choice test in high school and you have a team and everyone on the team has to agree on the answer that you're come up with. And you go out and you say, look, the answers are either A, B, C, or D. And your team comes to you and says, we've spent a lot of time on this. We think answer it's option A. And you say, actually, I've spent all week on this, and I can show you exactly how option A has been falsified. And they say, look, you make some good points, but if you can't tell me if it's B, C, or D, then we're just going to go with option A. And then I say, well, like, I can't tell you if it's B, C, or D. I haven't done the work on that yet, but I just know it's option A. It's irrational to say we're going to stick with A because you don't know if it's B, C, or D. So with that preface, the eclipses. There's something called a selenelian eclipse. It's a type of lunar eclipse where the Earth is supposed to be getting in the middle of the sun and the moon and causes the eclipse. But the selenelian eclipse is one in which the eclipsed moon and the sun are visible at the same time. It shouldn't happen. And what mainstream science says, and I quote some science article, like mainstream science article, and they say this should be impossible. It seems like it's impossible. But the explanation is refraction. The light is bending, so what you're seeing is a mirage, which to many people, including me, sounds just a bit like a rationalization. That means what you're seeing is an illusion. It's not actually there. What you're seeing, it's below the horizon, but it refracts up, so it looks like, and that's the explanation they need to give under the globe cosmology. Another interesting anomaly is that with eclipses, when you have the sun and moon looking almost like they're the exact same size. But the moon is only 238,000 miles away, allegedly, and the sun's supposed to be 93 million miles away. And the ratio between their sizes and distances just happens to be such that it looks like they're the same size when there's an eclipse. That seems pretty far-fetched because in reality, it looks like they're the same size and probably the same distance, maybe way closer than we've been told. So maybe that's true. So I've heard a bunch of things with the eclipses. One, saw this the other day. The idea is that the what we call an eclipse is just interpreting that one thing is moving, one body's moving in front of the other, when in reality it's actually that these, like the moon, is being charged up and charged down as a self-luminous body. And it looks like in its eclipse, but it's actually that it's lighting up and then charging or something like that, that the moon might be something totally different than we believe it to be. I've also heard, and I mentioned this in the book, in Vedic astrology, there are these gods called Rahu and Ketu, which some believe are basically bodies in the sky that can block light. They can get in the way of light, so it looks like there's an eclipse, but it's actually just these bodies that we haven't identified. And maybe that's an analog for the moon charging and discharging. I don't know. But the point is, there might be stuff way outside of our knowledge that's explaining the eclipses beyond just the basics. Because what we're told is this very basic thing of, yeah, like the Earth gets in the middle of it, and yeah, the sun and the moon are this far away and different distances, but they look like they're the same size. There might be a lot more.
Right on. Let's talk about some of the things that people can go out and observe for themselves. There's very relatively inexpensive cameras and pieces of equipment that people can get to check out some of these things, telescopes. What would you recommend?
Well, the first thing is it has to do with curvature math that people are looking at often, where if we live on a sphere, technically, Earth is supposed to be an oblate spheroid, meaning it's slightly bulging at the equator, so it's almost pear-shaped, according to Neil deGrasse Tyson. But basically, it's a sphere, it's a ball. Then that ball has a radius value, meaning from the core to the side at the equator, is around 4,000 miles. And based on that radius value, we can calculate what should be out of your view as an observer, based on how high you are. Because certain things should be blocked literally by the curvature of Earth. It would be like if you're looking around a bend of something, you can't see around the bend because it's blocked by matter. So certain things should be blocked by stuff that you can't see. And I think what you're asking is, well, there are observations that you could run to say, all right, I'm running the math of the curvature of what I shouldn't be able to see. Can I see it? And you have to adjust for your altitude and for the atmospheric conditions, because sometimes it's harder to see when there's stuff in the atmosphere and so forth. But what seems to happen over and over again is people do this math, depending on where they are on Earth, and they are seeing things that should be blocked by a lot of curvature. And this is why there are so many people who are questioning the globe narrative, because they go out and they say, what? That should be miles below the curve, and it's not. What is happening right now? Or they say, people talk about the ship that goes out of view because it's going under the curve, going around the curve, and that's why the ship goes out of view. Even Aristotle mentioned this. But then you get a camera where you bring it back into view. You're basically changing the angular vision. There's physics behind this. But basically, the boat didn't disappear. You just went out of what you can see from where you are, but it's not because it actually disappeared below the curve. It just has to do with the way that we see in the physics of vision, in a sense. So people can run these observations themselves, and that was compelling for me, because if the spinning globe model were so secure, you'd think that all the agencies would be going out doing these observations and say, look, you can't see this. This is blocked by curvature. This is blocked by curvature, over and over again. But the reverse seems to be true.
Let's get into the speculation waters and discuss possibilities of what we are witnessing, what we are looking at when we see the stars and the sun, and possibly what we may even be on.
I would say this is an area that I am way less equipped to have theories about. And I think part of it's because we just know so little about what's up there. We're told these stars are light years away, but what if they're just way closer? What if all the stuff we see in the sky is so much closer than we've been told? And the cosmology that we've been taught is just based on inference after inference, where they have to presuppose that everything's so far away. So I tend to think, just a hypothesis, that this stuff's way closer, including the stars. Now I've heard people say that maybe these bodies, these stars, are like conscious entities. They actually are influencing our planet. Then you start to get to things like astrology. That's really interesting to me because I think I've come across a lot of intriguing findings within astrology. Um, I've also heard things about the wandering stars. So these are planets, and that's important. So planet, many people think that Earth is a planet, meaning it's one of them, because there's this heliocentric model where the sun's at the center, and there's Earth and Mercury and Venus, and they're in this various order. And Earth is one of the planets. But planet means wandering star. And what if Earth is not a planet, but actually its own body? Some would say Earth is a plane, not a planet. So a plane plus the T gives you the planets. And the planets, these wandering stars, are lights in the sky that do exist, and they have these different motions relative to the stars around them. And similarly, like I was talking about with astrology, maybe these are bodies that are somehow influencing what's going on here on Earth, on the plane of Earth. And I also, in my book, I quote Emanuel Swedenborg, who was around a few hundred years ago as a mystic. And he wrote a book called Other Planets, where he spoke about his consciousness being taken by angels to these planets, but his body stayed here. So what if some of the lights in the sky, or who knows, maybe all of them, there are other dimensions or realms of existence that just appear to us as lights, but there's a lot of stuff happening on them. I don't know the answer. And until we can actually start making direct observations, I think it's going to be really hard to know.
There's been other sort of fun theories that have emerged from the flat earth realms and people making observations and questioning reality. And that's the possibility that there are extra lands beyond what we have access to, and there may be some sort of ice wall surrounding Antarctica, things like this. Have you looked into any of these alternative theories?
Yeah, it's a great thing to mention because it comes up very often. And I want to preface this by saying I don't think it's currently possible to know the answer because we don't have the ability to observe all the things that we would need to observe. Number one, we'd want to have the ability to independently verify things from above us to see what's below. And we can't do that. I mean, there's SpaceX, there's NASA, and we can't fully trust what we're seeing from them. There are many anomalies that I talk about in the book. There's the ISS where they're supposed to be floating, and you've got a hammer floating in one hand, and the astronaut drops a playing card straight down, and he says it's a pocket of gravity while they're moving thousands of miles an hour. How would you know the pocket of gravity is right there? How is something falling when something's floating? My point is, there's a lot we don't know about Earth based on what's above because we can't explore that, and we have just these agencies telling us little snippets. We also don't know enough about what's below us because if Earth were a sphere, we'd want to be able to prove that by digging all the way down. And the problem is we've only been able to dig down under 8 miles, and the radius of Earth is supposed to be 4,000 miles. So our models of whatever our geologists are telling us, clearly they're models. And so we don't know what's below us. And we also don't know what's within Earth because there are restrictions in terms of where normal citizens can travel. There are restrictions regarding the North Pole, and there are also restrictions regarding Antarctica. There's an Antarctic Treaty of 1959, which restricts free and private access below the 60th south latitude. So some members of your audience might say, well, look, I know someone who went to Antarctica, but like going to one part of Antarctica would be like saying, I went to one part of San Francisco, and therefore I know all about all of North America. Like, we need free and private access to all of Antarctica to know what's there. But with those caveats in mind, the alternative to the spinning globe that many people are purporting is the idea that Earth is a plane, meaning it's a topographical plane. So it's flat, but not really flat because there are mountains and valleys. And it might extend out well beyond where we know because we haven't been able to explore everything. And at the center of this plane of Earth is the North Pole, magnetic north, meaning anywhere you go directly away from it is south. And due east or west takes you in a circle around it. So that's circumnavigation on this flat plane. The problem is, the next part of it is that Antarctica on the plane model is not a continent floating in the ocean. Instead, it's a circle around the lake of Earth. So basically, if you took the sphere model, the globe model of Earth, put all of that inside a circle, and then put an ice wall around it. That's what Earth is under the flat framework. Some also go a step further and say, if you went outside of Antarctica, which they believe is this ice wall, if you went beyond it, there are many, many other lands. So what you're calling extraterrestrial beings, these are beings that do exist, but they come from the extra territories, well beyond. So Earth is just this one little circle on a plane that's got a lot of other land. And there's some anecdotes, and I quote in my book some books of people who claim they have been past the Antarctic ice wall and they've seen things in other civilizations. I'm not going to speculate because we need to have some like direct observations of that. But it's an interesting thing to consider because it's very suspicious to me that we're not allowed to travel to these places. And it was 1959, and you had the US and the Soviet Union that were supposed to be enemies in the Cold War agreeing to this. And they also agreed to a space treaty. Like, what's going on? Why would countries around the world agree to an Antarctic treaty to restrict access? Often they talk about environmental concerns. And that's one of the reasons it's really hard to travel around there is you have like these restrictions with we need to protect the environment and so forth. But I think it's suspicious, and it's important to have these conversations because to me, if the truth is as it is, then why not just show it to everyone? Why have these restrictions?
Yeah. Earlier, you mentioned some of the problems with gravity science, and I was speaking with a few people recently that were presenting theories about the possibility of flat Earth, and they were mentioning gravity. They also mentioned the North Pole, how some believe that there may be some magnetic force underneath or near the North Pole that is dictating what we understand as gravity.
Yeah. So under the flat Earth framework, the North Pole is at the center, and that's the magnetic north. So that would indicate there's something that's pulling there. What that is, I know there are a lot of different theories on it. But gravity, generally speaking, so when we say gravity, most of us are taught to think it means that mass is attracting mass, that the apple's falling to the ground because the mass of Earth is so big. And then Einstein said, well, the mass of Earth is bending space-time, so the apple falls that way. But as discussed, that whole house of cards seems to fall apart because it requires dark matter to exist, and that's now been falsified. And the falsification, by the way, from Pavel Krupa and his colleagues, he says it's above 5 sigma statistical results, meaning it's 99.99999% sure that they falsified it. The question then becomes, how do we explain this motion? Because we know things are falling and we know there are forces out there. And what many people speculate, and even including Stephen A. Young, the theoretical physicist I mentioned, who wrote A Fool's Wisdom, that we can explain the reason that objects fall is because of density, buoyancy, and electrostatic forces. So density is an object that's, the apple's denser than the air around it, therefore it falls down. Helium gas is less dense than the air around it, and therefore it rises. And then the question becomes, why is there a downward bias for things that are denser? Like, why wouldn't it go sideways? Why does it have to go down? And what people are often referencing is a downward electric current that's just inherent to Earth that has been measured by people like Richard Feynman, a famous Caltech physicist who I quote in my book from one of his lectures decades ago. He talks about this downward electric current. And we do know from many scientific studies, and I cite this in the book, of thunderstorms changing the rate at which objects fall. And I mentioned the Hutchinson effect earlier, where there's an ability to levitate large objects using something around electricity. So the point is that there could be electricity, there can be magnetism, forces that we do understand to some degree that can explain various forms of motion without invoking gravity. Because gravity has a specific connotation and really a definition that it's mass attracting mass. It's why it falls. Again, we're not questioning whether the apple falls. It's what's the mechanism. Why is it falling? That's what we're questioning. And what I guess many people are saying is there are forces that we know about that we have demonstrated very clearly that could explain these things too.
I am very interested to see how our future unfolds as it relates to our science and understanding of astronomy and the cosmos, because more and more independent researchers like yourself are making these observations that there's some fundamental problems with our current science and things are inconsistent and they don't make sense. And as our technology develops and we have access to better technology to make these observations ourselves, I don't see how this deception can perpetuate itself in the future. What do you think?
I would agree with you, except that I found people are extremely stubborn. And this one is particularly hard to believe. Like, it doesn't matter what you show someone, they'll say, no, there can't be that all these physicists are wrong from so many different angles. I don't believe it. So I do think, like with everything, it's going to be grassroots. Individuals are going to have to do their own critical thinking and put the pieces together and come to their own beliefs. And I think that's what's happening. We're seeing it with independent media, shows like yours, where the questions are being asked and more people are being drawn. The audience sizes are growing across the board for these independent media platforms because we're seeing, whether it's politics or otherwise in science, the narratives we're told are repeatedly shown to be false, demonstrably. So then it's like, well, you're putting forth a narrative. Why should I believe it if you were wrong all these other times and you're doing it with such conviction? How can I believe you? It's just at a certain point, people are waking up to it. And I do think the technologies probably will help, but it's going to be up to the people to do their own critical thinking.
On. Well, Mark, this was fantastic. We'll definitely have to do it again in the future. So much more we could get into. Before you go, let the audience know how they can pick up the book and find out more about you.
First, I want to thank you so much for having me on the show and for having this show to have a platform for so many important ideas.
Thank you.
All my books are available on Amazon. They're in hard copy, Kindle, and Audible formats. The newest one that we talked about today is An End to the Upside Down Cosmos. Subtitle is Rethinking the Big Bang, Heliocentrism, the Lights in the Sky, and Where We Live. And I also have a podcast series from 2019. It's only 8 episodes. It hasn't been continued, but I still get comments about it because it's relevant. It has to do with the nature of consciousness and the afterlife, reincarnation, and so forth, psychic abilities. I interviewed many scientists, including a Nobel Prize winner in physics, Brian Josephson. So very credible people I interviewed on the show. And there's a lot of evidence that our consciousness is not coming from our brain and that we all have psychic abilities and that life continues even after we die as a physical body. So that's called Where's My Mind? It's on Apple Podcasts, Spotify, and all the major players.
Excellent. Mark, thank you so much. Like I said, we'll be doing this again. And until next time, everyone, have an excellent evening. We'll talk again tomorrow. See y'all then. We live in an incredible age of information. More and more, we're discovering that we've been lied to and misled about much of our human history. Cory Hughes is providing profound revelations about World War I, World War II, the JFK assassination, Martin Luther King's assassination, and much, much more on his new Substack, Bloody History. Subscribe now for as little as $5 monthly. Just click that link right in the description to get started now and learn about our true history.